Hi, let's continue with our chapter 3, subtopic 3.1b. Use the sum formula. Sn is equals to n over 2 2a n minus 1d, or Sn is equals to n over 2a plus l. The sum, hasil tambah. Let Sn be the sum of the first n terms in arithmetic sequence. So the formula is either Sn is equals to n over 2 2a plus n minus 1d, or Sn is equals to n over 2a plus 1a plus l. L is the last term. So it is either one. Can be used both. Okay. Example 1. Find the sum. The sum. Hasil tambah. The sum is Sn. Of the arithmetic series 8 plus 11 plus 14 plus 17 plus 47. The last term is 47. So, find the sum, Sn. We need to find how many terms do we have between 8 until 47. So, using the formula before, in previous lecture, Tn is equals to a plus n minus 1d, which is equals to 47. So from the series given, the a is equals to 8. So this is our a. 8 plus n minus 1d. How to get the d? d is equals to 11 minus 8, which is equals to 3. So substitute 3 here, which is equals to 47. Simplify the expression. We have 8 plus 3n minus 3 equals to 47. So 3n is 8 minus 3 is equals to 5. This equals to 47. So therefore 3n equals to 47 minus 5. 3n is equals to 42. Therefore n is equals to 14. So between 8 until 47, we have 14 terms all together. So we need to find the S14. S14 by using the formula Sn. So this one I choose the formula n over 2a plus l. Why I choose this one? Because we have last term. The last term is 47. So now replace our n with 14. So 14 over 2. Now we know our a. Our a is equals to 8. So substitute with 8. And our L is equals to 47. So substitute L with 47. And now calculate the answer. So the answer is equals to 385. So this is the answer for example 1. Now proceed to example 2. Find the sum of the first 50 odd natural number. First 50, the sum of the first 50 odd natural number. So list down all the odd number between 1 to 50. Odd number. So the number is 1, 3, 5, 7, and so on. So it is clearly we have this is arithmetic sequence because every number increase by 2. So from this list, we have A is equals to 1, the D is equals to 3 minus 1, which is equals to 2. So how many number we want to find? 50 number. So using the formula, Sn is equals to n over 2 2a plus n minus 1d. Why I choose this formula? Because I don't have the last term. Okay, now substitute n with 50. So we have 50 over 2 because we want to find the first 50 terms. 2 times 1 plus 50 minus 1, d is equals to 2, and simplify the calculation. We have the answer is equals to 2,500. So the sum of the first 50 odd numbers is equals to 2,500. Now proceed to example 3. So this is the combination of lecture 1 and lecture 2 for subtopic 3.1 because we have Tn and Sn here. So in an arithmetic sequence, the 10th term, so this is T10. So T10 is equal to 3, and the sum of the first 6 term, so this is S6 is equals to 76.5. So the question A asks for the first term. So A, what is our A, and common difference. What is our D? Now let's solve this example. So T10 is equals to 3. So we have the formula for Tn. The Tn is equals to A plus n minus 1d. So A plus 10 minus 1 equals to 9, 9d equals to 3. So now we have A is equals to 3 minus 9d. So assuming that this is equation 1. By using the second information given, the sum of the first 6 term is 76.5. So this is the formula for Sn, which is 6 over 2, 2a plus 5d. 6 minus 1 equals to 5d, which is equals to 76.5. Simplify the term. So 2, 3, so we have 6a plus 15d is equals to 76.5. So assuming this is equation 2. Simultaneous equation 1 into with equation 2. simultaneous equation 1 with equation 2, where substitute equation 1 into equation 2. Substitute equation 1 into equation 2, then we have 6 times 3 minus 9d plus 15d is equals to 76.5. Simplify the expression, we have 18 minus 54d plus 15d is equals to 76.5. Then negative 54d plus 15d is equals to negative 39d, and 76.5 minus 18. Bring the 18 to the right hand side. We have negative 39d is equals to 58.5. So therefore d is equals to negative 1.5. So now find the first term by substitute d equals to negative 1.5 into the equation 1. So therefore, A is equals to 3 minus 9 times negative 1.5. Then the answer for A is equals to 16.5. So the first term is 16.5, and the common difference is negative 1.5. Example 3b. Find the number of terms, this is n, so that the sum is 0. So this is Sn is equals to 0. Find the n terms if Sn is equals to 0 by using the first terms. A is equals to 16.5, and the common difference d is equals to negative 1.5. Okay, so the formula for Sn is equals to n over 2 2a plus n minus 1d. Substitute a with 16.5 and d is equals to negative 1.5. Therefore, so 16.5 times 2 is equals to 33, and negative 1.5 is equals to 3 over 2. N is n. 2 times 0 is equals to 0. So now simplify the expression in the bracket. So we have 66 minus 3n plus 3. So the 2 is over 2. 2 times 0 is 0. So this is our expression. So now we have n 69 minus 3n is equals to 0. Therefore, n is equals to 0 and n is equals to 23. But always know that n cannot be equals to 0. Therefore, the answer is n is equals to 3. So now we want to find the relationship between Tn and Sn. So Sn is equals to T1 plus T2 plus T3 until Tn. The Sn minus 1 is T1 plus T2 plus T3 until Tn minus 1. So, assuming that this is the first equation, then this is the second equation. So, equation 1 minus with equation 2, we have Sn minus Sn minus 1 is equals to, so all we need to subtract. Then we have Tn is equals to Sn minus Sn minus 1. So this is the relationship between Tn and Sn. So we need to remember this formula. Example 4. The sum of the first n term is given by Sn is equals to 2n plus n squared. The question is deduce. Deduce an expression for the n term and the common difference. To find the Tn, we need to use the formula Sn minus 1. So, given Sn is equals to 2n plus n squared, and the formula for Tn is equals to Sn minus 1. So now, substitute Sn with 2n plus n squared. The Sn minus 1 is 2 times n minus 1 plus n minus 1 squared, all squared. Now simplify this expression, then we have 2n plus n squared minus with, simplify in the bracket first, so we have 2n minus 1, minus 2, plus expand n minus 1 all squared, then we have n squared minus 2n plus 1. So here 2n can be cancelled out. So we have 2n plus n squared minus 2, which is equals to plus 2 minus minus. So this is minus n squared minus 1. So n squared here can be cancelled out. So then the answer for Tn is 2n, 2 minus 1 equals to 1. So the answer is Tn is equals to 2n plus 1. Now proceed to the second question to find the common difference. So by using the formula Tn is equals to Tn minus 1. So we know that the Tn before is 2n plus 1. So therefore 2n plus 1 minus with 2 times n minus 1 plus 1 is equals to 2n plus 1 minus, simplify in the bracket first, 2n minus 2 plus 1. So we have 2n plus 1 minus 2n minus plus minus 1. So 2n can be cancelled out. So therefore we have d is equals to 2. So this is a constant. So the answer for d is equals to 2. Now we proceed to the second example. Find the sum of 11 terms to 20th term. So now here we need to understand the question. What is the question asked for? So the question asks for the sum of 11 terms to 20th term. So here we have T1 plus T2 plus until T9, T10, T11 until T19, T20. So what is our question asked for? The question asks for the sum of the 11 terms to 20th term. So this is the question asked for. T11, the sum of T11 until T20. So now here we know that T1 until T10 is equals to S10. This is the sum of the first 10 terms. So, the T1 until T20 is S20. So, the question asks for T11, the sum from T11 until T20. So, how to get this one? So, it is actually equals to S20 minus S10. So, this is what we want to find. Okay. Now, proceed to the answer. So, what is S20? Given that Sn is equals to 2n plus n squared. So we are going to use this formula. Okay, so S20 is equals to 2 times 20 plus 20 squared minus with S10 is 2 times 10 plus 10 squared. Calculate the answer. Then we have, this is 440 minus 120. The answer is 320. Example 5. Find the first term and common difference of arithmetic series are a and negative 3. So it means that the first term is a and the common difference is negative 3. So the sum of the first 2n, so as 2n is equals to the sum of the 7n term. The sum of the 7n term. So we are going to use this relation to get a in terms of n. So S2n is equals to S7n. So now S2n, the formula is 2n over 2 to a 2n minus 1 times negative d, negative 3, d is equals to negative 3, and 7n over 2 2a plus 7n minus 1 times negative 3. And then simplify the expression we have. So this one can be cancelled out. This one is cancelled out. So we have 2 times 2a minus 6n plus 3 is equals to 7 times 2a minus 21 and 3. Okay. So simplifying the terms, we have 4a minus 12n plus 6 is equals to 14a minus 147n plus 21. So 14a minus 4a is equals to negative 12n plus 6 plus 147n minus 21. So we have here 135n minus with 21. 6 minus 21 is equals to negative 15. So we have 10a. So the a is equals to 135n minus 15 over 10. So Simplify the answer. Factorize the 15. So we have 9n minus 1 divided by 10. Therefore, the simplest way how to write the A is 3 over 2 9n minus 1. 9n minus. So this is the first term. Now we proceed to the last example, which is application of arithmetic sequence. In lecture hall has 50 rows of seats with 30 seats in the first row, 32 in the second row, and 34 in the third row, and so on. Find the total number of seats. So the number of seats in a row is arithmetic sequence or arithmetic progression, which is the first row is 30, second row is 32, the third row is 34, and so on, which is arithmetic sequence. So with A is equals to 30, B is equals to 2, we need to find 50 rows. The number of 50 rows, so as 50. Substitute the answer into the SN formula, which is S50 formula, which is 50 over 2, 2 times 30 plus 50 minus 1. B is equals to 2. So the answer is equals to 3,950. So that's all for this video, lecture 2. So before we end up our class, please solve this exercise and submit the answer to your lecturer. Okay, that's all. Thank you.